Okay, so here we go. We have section 3.2. We have defined in the first video, we defined for everybody the the angles that are formed if we cross, if you will, two parallel lines with a transversal. So if we do that, we get eight angles formed. So here is a line, and I will give you that these two lines are parallel. So let's say this is line L and this is line M, and they are parallel. So let's bring up a nice green transversal. I want a little more lime green, so let's have a line green transversal here, and this transversal cuts both lines, and we end up with several, as you know, angles. We have alternate interior angles, we have same side interior angles, and we have corresponding angles. So let me do this carefully, and I'm going to use the same writing that we had in the book. So we labeled this in the text here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the same labeling that is on page 74. So if you want to follow along in the book, and I think that's probably an easy thing to do, we have one postulate and 3 theorems that are introduced in section 3.2. And you're going to be using these the rest of the year, and in fact you're going to be using these the rest of your mathematic career, whether it's in geometry, analytic geometry, whatever math class you're going to take. Now, postulate 10 and theorem 3.2 and theorem 3.3, basically, I think you might guess, even though I've asked you not to use the it looks like it theorem, if I had you look very carefully here at, let's say, and we'll go to postulate 10 here, two lines are cut by a transversal, the corresponding angles are question mark. Well, there's a corresponding angle right there, and excuse me, I wanted that in yellow, and there's a corresponding angle there. If you were a guessing person or using the it looks like it theorem, corresponding angles are congruent. So this means that angle 1 is congruent to angle 5. Angle 3 congruent to angle 7. It means that angle 2 is congruent to angle 6, and it means that angle 4 is congruent to angle 8. Those are corresponding angles. Now, if you continued and you, with the it looks like it theorem, and you look at theorem 2, we'll talk about the alternate interior angles. So there are two pair. So alternate interior are here and here, here and here. Remember, alternate across, and interior means interior to these two parallel lines. So alternate interior, and if you use the it look like it theorem, you will say that they are congruent. So angle 3 is congruent to angle 6. Angle 4 is congruent to angle 5. All right, so we have corresponding angles, and we have alternate interior angles. So we still have same side interior. So the same side interior are interesting. Same side interior, INT, and same side interior 3 and 5 and 4 and 6. Well, as it turns out, if you look at if you use the it looks like it theorem, 3 and 5 and 4 and 6 are supplements, so 3 plus 5, the measure of angle 3 plus 5 plus the measure of angle 5 is 180. And similarly, the measure here, I can't write it here, measure of angle 6, measure of angle 4 is 180. So we've pretty much got everything covered here. Exterior angles up here, 1 and 2, corresponding alternate interior angles. We've pretty much got everything covered except for theorem 3-4, which says it's very, very simple. It says, look, let me grab a different color for another transversal here. Let's have a nice pink. Well, we've already got a pink. Let's have a nice light blue. So my game, you know that we have two parallel lines here. So I'm going to add this nice light blue transversal. So we have this line L is parallel to M, that is given. Now we have this nice new transversal, which is light blue. Theorem 3-4 says this. If this line, this nice blue line, if we are told that it is perpendicular to line L, and we know these lines are parallel, then this theorem 3-4 says it is also perpendicular to line M. And if you think about that, it makes total sense. So your work is going to involve all of these theorems. And listen, I'm going to highly recommend once again that you take the time to write out a card. And that card would have a drawing of two parallel lines, your listing of corresponding angles, alternate interior angles, same side interior angles, what transversals are, and so forth. And I will on the next sections. Hi guys, this video is going to try to help you while you're on the road in Chile, and I'm going to, in this one video, introduce sections 3.1 and 3.2 at the same time. And if you're following along in the book, and hopefully you downloaded your PDF file for the text, I'm on pages 73, 74, then there's homework, and then there's, in section 3.2, there are some more postulates and theorems, and those are on page 78 and 79. So let me start off, and I just want to give you an overview and go over some definitions here that you're going to see. So I guess, obviously, the first definition is parallel. What is meant by parallel lines? What is meant by skew lines? And really, this is, you probably understand this pretty well, but we've defined a line as a geometric figure such as this. It's composed of a continuum of points. And we often label it by 2 points, A, B, but also get used to saying that maybe that this is line L. Okay? And common for us in this section to say, all right, we have a second line, and this is line, let's say, M. And if we want to, in the nomenclature, say that these two lines are parallel, what you'll see in the text, and what you will see pretty much everywhere, is line L is parallel to line M. And it's this double hash here that means parallel. It means they do not intersect. So if you look carefully, please, on page, at the introduction of chapter 3, on page 73, they take a great deal of time to talk about parallel lines and then skew lines. So parallel lines are lines that are in one plane that do not intersect. They do not intersect at all. Skew lines are lines that are non-coplanar. So they are neither parallel nor intersecting. So I generally speak of simply, here we have parallel lines or non-parallel lines, and by that I mean they are in the same plane. So here is our diagram. We have two lines, line L and line M. And I've told you how to look for in the text and how to represent that. Okay, I'm going to change some colors here. Now, what we're going to do is have these two parallel lines, and we're going to cut them by another line that cuts both of them. Like that. And this line is called a transversal. And when we say transversal, we're generally going to assume that this line cuts both of these two parallel lines. Now, carefully look at this and look above, inside, and outside these two lines cut by this yellow transversal. You will see that we have 1, 2, 3, 4, 5, 6, 7, 8 resulting angles. These resulting angles all have specific names. So, if we have alternate interior angles, well, it is as it sounds. We have interior, and what that means is interior to the parallel lines. We have 1, 2, 3, 4 such interior angles. And in this case, we say alternate interior. Now, alternate means opposite. So in this case, 2 and 4 are opposite pairs of alternate interior angles, as are 1 and 4. Similarly, if we want to look at same side interior, those would be 1 and 3, as well as 2 and 4. Same side interior. Now, you guys, make a card on this. Totally fine, and I encourage you to make a card with all of this information on it. And again, I'm right on page 74 in your text, so you'll be able to follow along easily as well. Now, corresponding angles are two angles in corresponding positions relative to these two lines. So let's go grab yet another color here and say corresponding angles, again, correspond to positions relative to the two lines. So we might want to label further here. So 5, 6, 7, and 8. It's probably a little unfortunate I didn't use the same numbering as the book, but that's okay. Corresponding angles refer to the same side. So we have corresponding angles in this case are 5 corresponds to 3, and 1 corresponds to 7, 6 to 4, and 2 to 8. So we have 4 pair in there. We have 4 pair of corresponding angles. Now, those are all the definitions that really we're going to use for the rest of the year about parallel lines. Once again, parallel, they do not intersect. And we assume that they're in the same plane. We have 2 lines, and if we know that these 2 lines are parallel, here is how we know that. L is parallel to M, and you'll see that in the text and everywhere, SATs, etc. We have 1, 2, 3 types of nomenclature for the resulting angles. So if you simply draw 2 parallel lines, use a yellow here if you will, transversal, which is that. Then you create 8 angles. All 8 of those angles have special names. So now the next page, or the next video, I'm going to talk about some of the theorems that involve these angles.